Hi everyone, welcome back to my channel. In this video, we're going to talk about landing zone, AWS VPC landing zone. We will also try to see how to create AWS VPC landing zone using Terraform. So with one click deployment, you will be having all the things in place where you just have to type in Terraform, apply, and the magic happens. So if you're wondering what is a landing zone, an AWS landing zone is a secure, standardized environment within your AWS account that serves as a foundation for building or deploying workloads and applications. It's like a pre-configured staging area with all the things in place. So now, why do we use landing zone? So we use landing zone for three reasons. The one is standardization and best practices. So this AWS landing zone enforces best practices for security, access control, networking, and logging. So this consistency makes managing your environment easier and it reduces the errors as well. The second important thing is security baseline. So this landing zone establishes a baseline security posture for your account. So this includes features like IAM policies, logging, configurations, and VPC settings to keep your resources secure. And the third one, and the last important thing is organization and scalability. Even in a single account, a landing zone can help you organize resources logically. So this makes it easier for you to find and manage resources in your environment as the resources keeps on growing, right? So that's about landing zone. Now let's talk about the architecture that we are interested. When you say a landing zone, these are all the basic things that are required in your AWS account. I'm not saying this is the only thing that you have to bring in your account. No, this is a basic VPC landing zone that should be there in your AWS account to create any other resources. For example, you have to create an EC2 instance. You will have to have your own VPC other than the default VPC that we get as part of the creation of AWS account. So in this, we will have everything in place. You just have to go ahead and create the EC2 instance in whichever the subnets that you want, right? So that's the basic idea. Now let's try to understand the architecture first, and then we will see the Terraform code also. Okay. So to do that, first what I've done is, this is the basic architecture that I've built. For this demonstration, I'm going to use US East. Ohio is my region. And in this region, I'm creating a VPC. I've named it as AMC VPC, but here it shows default, but ignore that. So I'm going to create a VPC. And in VPC, I'm also going to create, what I'm doing is I'll be deploying it in three different availability zones. So as my region is US East 2, I've selected 2A, 2B, and 2C as the availability zones. In these zones, I'm going to create public subnet and a private subnet each, right? Apart from this, as you know, we need internet gateway to be able to communicate with the internet. So I'm going to create a internet gateways and attach it to the VPC as well. So if you see here, I have public subnets in all the three availability zones, and I also have a private subnet. Let me zoom in a bit. Okay. Let me try to explain one particular availability zone, and the same thing applies to the other as well. So if you see here, I have a public subnet and I have a public subnet route table. Basically, if I have to communicate with the internet or anything available outside of AWS, what I need to do is I need to have something called as internet gateway. So I've created that, and what I've done is I've attached to the VPC directly. Now my communication flows via internet gateway in the public subnet. Whereas in private subnet, what I've done is I've created a new route table, and in that route table, I've also enabled the communication to the internet, but it goes via NAT gateway. So I've created a NAT gateway in the public subnet. That's the usual thing that we follow in AWS. The NAT gateways always should be deployed in the public subnet. So I've deployed that NAT gateway in the public subnet. And for that NAT gateway, you will have to associate a elastic IP. So I've done that as well. So once you do that, In the route table of private subnet, you will make the connection to flow via the NAT gateway, and it reaches the internet gateway and it goes to the internet. So this is the architecture in US East 2A. And the same thing happens in 2B as well, just fast forwarding whatever we thought. So here also we have a public subnet. Okay, we also have a private subnet, a route table for a public subnet, route table for a private subnet. Private subnet connections or the traffic is going via again a NAT gateway that we created, and we also have an elastic IP associated, and it goes via internet gateway. And the same thing happens in the US East 2C as well. But you can deploy this in two ways. One, by using the AWS console and it goes via manually. And I don't prefer that. In fact, all the organizations are using something called as Terraform or infrastructure as code tools. So in this video as well, we are going to use Terraform to deploy this architecture. So what I've done is I've created a folder called as landing zone. Let me open that now real quick in VS Code, so you will be able to understand that. Okay, so let me close all of them, and first I'll explain the files that I've created. So mainly you can see the folder named AWS VPC landing zone Terraform, and inside that I have these many files. So let me walk you through what things I've placed in each of these files. So in main.tf, what I've done is I've just created the VPC. For example, if you see, I've created AWS VPC, and the name that I've given is AMC-VPC. And the CIDR block, I'm fetching it from the var or variables.tf. Let me explain that further. But before that, the main important file that we have to concentrate is providers.tf. So here I'm mentioning the Terraform version. So this is the Terraform version, and I'm also specifying the provider, which is in my case, it is AWS. I'm interacting with AWS, and the region that I'm interacting is US East 2. That is what we also discussed in the diagram as well. So this is the first file actually. So after having discussed this, next in the main.tf, as you already know, I'm creating the VPC. Next, what I've done is to make your life easy. What I've done is I've differentiated between public resources and the private resources. So now what is public resources? So all the things that are in public subnet, including the public subnet, I'm calling them as public.tf. So for example, public subnet, route table of public subnet, elastic IP address, NAT gateway, internet gateway, all these are public things. So what I've done is I've created them in the public.tf. In the same fashion, private subnet, private route table, all this I am creating in the private.tf. So let me go back to my files here. If you see, I have private.tf and I also have public.tf. Before that, I'll also show you what is there in the variables.tf. So in variables.tf, what I've done is I've defined few variables that are required for my creation of resources. So let's go one by one and understand the first I'll go through public.tf. Okay, if you see here, the very first resource that I'm trying to create is the internet gateway, because if you go back to our architecture diagram, so after creating a VPC, I've done this in the main.tf, and very soon after the creation of VPC, I'm going to create a internet gateway. So I'm creating that here. If you see here, I'm creating AWS internet gateway, and the name of that is, this is just a logical name, and the VPC ID, I'm getting it from the main.tf file. So I have a name called this one, AWS_VPC and AMC and -VPC. I'm getting that, I'm pasting that here, right? With the ID. So I'm fetching that details here. I hope I'm clear on this one. Next thing I'm doing is I'm creating three different subnets. Public subnet A, public subnet B, and public subnet C. So if you're wondering why I'm placing public B here instead of A, that doesn't matter at all. You can place wherever you want, right? So for example, let me go back to the diagram. This is, let's call this as public A, this as public B, and this is public C. So this is what I'm doing here. So I'm associating this with the same VPC here, the same VPC ID. The CIDR blocks, I'm fetching it from the variables.tf. Now let me go back to variables.tf. If you see here, I've created a variable called subnets with the type as map. Map is just a kind of a dictionary in your coding language, I would say. So here I've defined three things. One is ABC, and I've given the IP address range for the same. So if you see here, for A, I'm using 10.0.0.0.1.0/24, and similarly for B, it is 2.0, and C, it is 3.0. And for the private subnets, I'm doing the same. I'm using the same map. But here, if you see, there is a 4.0, 5.0, and 6.0. And in the same way, I'm using the VPC cider, which you saw in the main.tf. The default range is this one, that is 10.0.0.0/16. Okay, so I'm using this in the main.tf. I'm referring that. Okay, so I hope I'm clear on this one. Now let me go back to the public .tf again. So this is what I've done here. These three blocks are creating the AWS subnets, and the cider block, it is fetching from the var.subnets.a for public subnet A. For C, it is subnets.c, and for B, it is subnets.b. So this is fetching from the variables.tf file. Next, what we need to do is, after creating the the subnets, we are creating the elastic IP address, because we need that for the NAT gateway. So if you see here, if I go back to my diagram, I also have a NAT gateway, and I need to associate it with the elastic IP. So that is what I'm doing here. Let me go back. So I've created an elastic IP, and I'm just using the tags here. Next, I'm going to create the NAT gateways itself. If you see here, these are the NAT gateways that I'm trying to create. AWS_NAT_gateway. So for the NAT gateway sitting in availability zone US East 2A, I'm naming this one, for 2B, for 2C. So, and I also need an allocation ID. As I told you, I need to wait till the AWS Elastic IP is created. So what I'm using here, I'm using a special function called depends on. Basically what it will do is, it will wait for until the Elastic IP is created. So once the Elastic IP is created, after that I need to fetch something called as allocation ID. Basically when you create a Elastic IP, it will be associated to your AWS account, and that will create a allocation ID. So we need that for referencing to the NAT gateway. So that is what I've done here. And the subnet ID. So if I want to place this NAT gateway in public subnet A, what I need to do? I need to reference the subnet ID, right? So that is what I'm doing here. If you see here, subnet ID, AWS_subnet, public _A and ID. So if you see here, this is what we have created, right? Here, the same thing I'm referencing here, okay, in the NAT gateway as well. The same thing I've done for all the three NAT gateways. These three blocks, we are creating the NAT gateway in the three different availability zones. 1 here, 2 here, and 3 here. Okay, so I hope I'm clear on this. What we have done so far, we have created the public subnet, we have created the Elastic IP, we have created the NAT gateway. Now what is remaining? The route tables needs to be created. So let's see how to do that. So in the next block, we are creating the route tables. If you see here, we are creating the route tables and associating the route tables to the subnets and all those things. So if you have already known, if you have already gone through the AWS VPC things, so you should be knowing that a route table is created. And once you create a route table, you need to create a route in that. And then you also need to associate that route table to a subnet. So that is what in these three blocks are doing. So in this block, I'm creating a brand new route table. I'm renaming that as route table public A. So this needs to be associated with the VPC. So I'm referencing the VPC ID also. And then I need to associate this route table to a particular route or a subnet. So what I'm doing is, this is what I'm creating, AWS route table association. I'm calling that as route table association public A. And to which subnet I need to associate, that is what I'm specifying here. For the route table A, I need to use the public subnet A. That is what we are doing here also in the diagram. If this is a subnet A, I need to associate or create a route table for that, and I'm associating with this subnet. So I've created or referenced the subnet here. And what is the route table ID? If you're wondering, I have not created a route table itself. How am I going to get the route table ID? You don't have to worry about that in Terraform. So you just have to reference this. For example, AWS route table, and what is the name and .id. That's all. So in a simpler way, if you do not understand how to get that, so what I'll do is I'll just copy this. Okay. Then what you can do, if you paste it here, this is just for your understanding. I'll remove all the double quotes. Instead of double quotes, use a dot in between. And after this, add a dot and ID. That's all. So that is what even I have done here. Okay. I hope I'm clear on this. Let me remove this block. Okay. Next, I need to create a route. Basically, what are all the things that are allowed in a route table? I need to specify. So that is what I'm doing here. As I told you, all the connection should go via the internet gateway. So if you see this code, it is pretty much clear. The destination CIDR block is basically wherever which are the IP addresses that are allowed to reach, right? So that destination CIDR block, I'm giving the entire internet. Quad 0 refers to your internet. So the gateway ID in my case is internet gateway. So I need to fetch the internet gateway ID details. Where do we have that? In the first one itself, we have created the internet gateway. I'm referencing the same here. Okay, so this is for the route table A. Similarly, I need to do that for the route table B and the route table C. So if you see here, this block is for the route table B, right? And the last block is for the route table C. This completes all the things, that is creation of all the resources inside the public subnets. Now, there is one block that is private subnets. So what I've done, I've already told you, I've created a separate file called private.tf. Let me go there. And if you know already, what are the things that we need to create in private subnet or private.tf? Private subnets and the corresponding route table, association of the route table, and creation of the routes. So those are the things that are pending. So let's see what we have done here. So if you see here, I've just created the route table first itself. But if you want to go one by one, if you see this last three blocks, I'm creating the subnets here. Private A, private B, and private C. Okay, so I'm referencing the VPC ID again, and I'm not keeping the public IP. I do not want to keep the public IP for the private subnets, so I've disabled that as or set it to false. And the CIDR block I'm fetching from the variables.tf, and in there private underscore subnets. Let's go there. If you see here, private subnet for A, I'm going to use this. For B, I'm going to use this. For C, I'm going to use this. Okay. Now let me go back to the private.tf. So this completes the creation of three subnets, private subnets. Okay. The same thing, but you have to just replace A by B, B by C. Okay. So that is what I've done here. Next, I need to create the route tables. So what I've done for creation of route tables, let me go back here. If you see here, the first block is creating the route table for private subnet A. Okay. And I'm associating with its VPC. And after creating the route table, you already know you need to associate that route table to a specific subnet. So I'm doing the same here. AWS route table association. I'm giving this logical name, and private subnet ID, I'm fetching it here. If you already know that, if I'm creating a route table here in this private subnet, this is route table private subnet A route table. So I need to associate it with the corresponding public private subnet. So that is what I'm doing here. Okay. After I'm doing that, I also need to reference the route table ID. So I'll get it from this route table ID. Okay. So the same thing goes here as well. And next, I need to create the route for specific route table, right? So that is what I'm doing. If you already saw the architecture, I mentioned that all the traffic coming from the private subnet will flow via the NAT gateway that we created in the public subnet. So if you go back to my file, so I'm creating a route called route private A, and here I'm referencing the private route table ID by referencing the ID here, and the destination CIDR block remains the same, that is quad 0. It needs to reach out to the internet, but the catch here is I'm using NAT gateway, but here in the public subnet I was using internet gateway. So to reference the NAT gateway, I'm using AWS underscore NAT gateway, and I'm using the particular NAT gateway ID referred, and I'm using this here. The same thing should be followed for the private subnet B here and for the private subnet C. Okay, so this completes the entire architecture. Okay, so this is what we are going to create now. So to do this, what I just need to do is I'll just open the terminal. Let me clear the screen to you once. Now let's go ahead and see if the Terraform is initialized or not. I don't think Terraform is initialized because I do not see any Terraform files created here. So let me just mention Terraform init. Okay, so it says Terraform not found. I'll just open ZHS. Now I'll just run the same command, that is Terraform init, and this will initialize the Terraform by installing all the providers and everything. Because if you see here, currently we do not have the providers and all, apart from the files that we have created. So let's wait for that to complete. So if you see here, it says initializing provider plugins. So let's wait for that to complete. And if you're wondering where can I find all these resources, I've given all the things in my GitHub repository. I'll show that to you as well. Once I'll also link that to the description. Now, if you see, it says Terraform has been initialized successfully. Now you see these two files that are created, .terraform and .terraform.logs.hcl. If you see here, provider information will be downloaded. So once it is done, let me clear the screen to you again. Let's go ahead and create a plan for this. Okay, let's see what are the things that Terraform is going to create as part of deploying these files. If you see that it is going to create 32 resources and 0 to change and 0 to destroy. So these are all the things that it is going to create. If you see plus icon here, that means it is creating those resources. Okay, let's do one thing. Let me clear the screen and do Terraform apply -- auto -- approve. So I'm applying this. Basically, it is going to create the resources in your AWS account. So if you see here, it started creating Elastic IP, A, B, C, and subnets. All those things will be created. So it will take a while for the resources to be created. So what I'll do is I'll pause the video and I'll come back once all the resources are created. All right. If you see here, it has created 32 resources and 0 changed and 0 destroyed. So it took around 3 to 5 minutes or 3 to 4 minutes to create all the resources. Now to verify this, let me log into my AWS console. This is my AWS console, and let's go to VPC. So under VPC, let's see what is the CIDR that we selected. If you go back to variables.tf, if you see here, VPC CIDR that I've selected is 10.0.0.0/16. So let's go back to my AWS console and see if you have that created. So if you see the VPCs, let me go there. And if you see, I've given a name called AMC demo, and that is being taken here. And the CIDR that I mentioned in the variables.tf is getting reflected. And if you see this, all the things are in place. Okay, this is the VPC ID. Now let's also see the resource map for this. This will give you a better context. If you see this is the VPC. And these are all the subnets that we created. For example, if I go back, we have 1, 2, 3, 4, 5, 6 subnets that we have. Out of them, 3 are public and 3 are private. All the things that you see in green color are public subnets. All the things that you are seeing in the blue color, those are private subnets. If you see here AMC demo, this is associated with corresponding this route table, and this is a public subnet. Okay, and the next one, AMC demo, is a private subnet, and this is the route table. So let's verify for one subnet what are the things that we have and what is the route table. So if you see this AMC demo, this is a public subnet. According to our route table configuration, the route should go via the internet gateway. Let's see if that is there in place or not. So if I open the route table associated, and if I see the routes, if you see the destination that we given is 0.quad0, and the target is internet gateway. So if I go back to my file and I'll just open the public.tf, I'll just close this one. And if you see this block, so the route table ID I've given that, and the destination cited block is quad 0, and gateway I'm using internet gateway. So this is in place, and by default this will be there. Basically this will allow communication within that entire VPC. This will be there for all the subnets that you create. And let's go to the subnet association. Let's see if the subnets are associated or not. If you see here, explicitly I've associated this particular subnet, which is public subnet. Okay, so this is in place. Let's go back and let's also see a private subnet and its configuration. I'll open the route table for private subnet A, and it should go via NAT gateway, right? Let's see that. Under routes, this is in place. This will be there for all the subnets. And if you see, the destination is 0.0 and it's going via NAT gateway, and the NAT gateway is created in the public subnet A. Okay, so this is also in place. So basically it has created all the things that are required for us in this demonstration. Okay, so if you see here, network connections, all are in place. Basically this is how you create the landing zone. Basically, if you want to create any things that you want, for example, EC2 instance or a cluster, EKS cluster to be created, you don't have to worry about the networking configurations because it is already in place. Then the only thing that you have to do is go ahead, create a separate file for a Terraform and create the EC2 instance or the EKS cluster or any compute or any things that you want, right? So this is how you create the AWS VPC landing zone. I hope I explained very clear to you, because this is a basic functionality that is required for a cloud or a DevOps engineer. I hope I made clear to you. If you're liking the content that I'm creating, please consider subscribing and share it among your friends. Thank you, and I will see you in the next one.